Today's lesson is Chapter 4, Lesson 7, Linear and Nonlinear Functions. Okay. Linear meaning form a straight line. Nonlinear would be something like this, this, or that. Those are just three examples. What will we learn today? To identify linear and nonlinear functions. Vocabulary. Nonlinear function. Functions whose rates of change are not constant.
Linear and nonlinear functions. Football. The table shows the approximate height and length traveled by a football thrown at an angle of 30 degrees with an initial velocity of 30 yards per second. Did the football travel the same height each half second? Consider the height the football traveled for each half-second increase in time. Find the change in height the football traveled for each half-second increase in time. The change in height is different for each half-second increase in time. So the football did not travel the same height each half-second. Did the football travel the same length each half-second? Find the change in the length the football traveled for each half-second increase in time. The length increases by 13 yards for each half-second increase in time. The football did travel the same length each half-second. Graph the ordered pairs, time, length, on a coordinate plane. Connect the points with a straight line or smooth curve. Graph the ordered pairs time height on a coordinate plane. Connect the points with a straight line or smooth curve. When you graph the ordered pairs time length, the graph is a straight line. It is a linear function. When you graph the ordered pairs time height, the graph is a curve. It is a nonlinear function. So, the next time you see a quarterback throwing a pass, think of linear and nonlinear functions.
Example 1. Determine whether the table represents a linear or nonlinear function. Okay. So a couple things here before we get into this. For a function to be linear, the rate has to be constant. So we need a constant rate, and that will make it linear. When we don't have a constant rate, or not a constant, that is non-linear. So let's take a look. The x's look like they are going up by 2, so that's constant, but we need both the x and the y to be constant for this to be linear. So from 2 to 20, that's plus 18. From 20 to 54, that's plus 34. Those are not constant. So therefore, this is a non-linear function. Our explanation: the rates are not constant. Another example, number 2, determine whether the table represents linear or non-linear function, or a linear or non-linear function. Again, if it's a constant rate, it will be linear. If it's not constant, it will be nonlinear. So let's take a look. 1 to 4, it's going up by 3, by 3, by 3. So my x is going up by 3. That's a constant rate. From 1 to 16, it's going up plus 15. From 16 to 49 is actually going up 33. Again, not constant, so this one is also non-linear. And the reason is because it doesn't have a constant rate. No constant rate. Our next example is a real-world example. Tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? So again, if we're going to have linear function, it's going to be a constant. So for this one, they're just asking us if it's linear, if it's a linear function. So we're going to have yes or no answer, a yes or no answer, and explain. So number of tickets sold is going up by 1. Ticket sales is going up by $5. So this is a constant rate. So we can say yes, it's linear. Our explanation, the ticket sales have a constant rate of $5. Our next example, another real-world problem. A square has a side length of s inches. Let me draw a square. And the length, we'll say here, side length of s. The area of the square, so the area is inside, let me color that in, is a function of the side length. So we know, if you recall, the area of a square is a side squared. So does this situation represent a linear or non-linear function? So now that we have the formula for area, what we have to do next is we're going to have to create a table. Okay. Let me make that table just a little bit bigger. Okay. We'll have the side length and the area. So for side length 1, we're going to take 1 squared, which is 1. For side length 2, 2 squared, which is 4. For side length 3, 3 squared, which is 9. And let's do one more here. For side length 4, 4 squared is 16. So we just create a table, and now we need to see if there's a constant rate. The sides are going up by 1, so there's a constant rate there. From 1 to 4, plus 3. From 4 to 9, plus 5. And you can see from 9 to 6, plus 7. So there is not a constant rate. Remember, for it to be a constant rate, all the numbers have to be the same. In this case, they're not the same. So does this situation represent a linear or nonlinear function? We're going to answer nonlinear. Explain. The area rate is not constant. So again, this lesson, we're determining whether examples that were provided to us are linear. In other words, they have a constant rate. And you'll recall that if there's a constant rate, it's going to form a straight line. Or if it's nonlinear, where there is not a constant rate, and if there's not a constant rate, it is going to form anything but a straight line.